For our next graph, we want to look at the function cosine x over 1 plus sine x. So we're going to start and pick apart what we can out of this. So the first thing we're going to look at is, like before, we're going to take a look at our intercepts. Our x-intercepts are when we plug in 0 for y. Oh, I was supposed to be a 0. My apologies. Okay, and we're going to multiply both sides by the denominator. So really, we're only looking for the places where cosine is 0. So think about your unit circle. Remember, cosine is the x term. So we have intercepts at pi over 2 and 3 pi over 2, and they keep happening. Okay, so this is going to be periodic. So at pi over 2, we seem to have an intercept, and then 3 pi over 2, and so on and so forth. Now, I'm not going to put those in yet, and I'll show you why in just a minute. If we go to our y-intercept, we're going to plug in 0 for x. So we have cosine 0 over 1 plus sine 0. Cosine of 0 is 1, sine 0 is 0, so our y-intercept is just 1. I will put that one in there. There it is. Okay. Now, the other thing that we want to think about is this is a trig function. Both sine and cosine have a period of 2 pi, so this function is also going to have a period of 2 pi. So you're going to see that it's going to do the same thing over and over. So we'll just kind of keep that in mind. Now, asymptotes. We don't have any horizontal asymptotes, but we do have vertical asymptotes. The vertical asymptotes are going to happen whenever our denominator is equal to 0. So our vertical asymptotes happen when the sign is -1. And if you think about the unit circle, that happens at 3 pi over 2. And it's going to happen every time around, so it's going to happen every 2 pi. And so that's why I didn't graph this intercept, because it's actually an asymptote. So at 3 pi over 2, we have an asymptote. And then the other asymptote is going to be at -pi over 2. And then the other one's going to be way down here, okay, because this is a periodic function. So it's going to be the same thing over and over. So our vertical asymptotes are 3 pi over 2, plus they happen every 2 pi n. All right, what else do we want to find out about from this? Symmetry, we're not going to have any symmetry here. We can already see that from our asymptote setup, that there's no symmetry. Our domain is going to be everything except for those vertical asymptotes. And we don't really need to talk about limits because clearly we have asymptotes happening. It's not really appropriate to talk about left and right hand end behavior when you have infinite number of vertical asymptotes. So I think we're about done with this portion of it. Yeah. So, oh yeah, we did have that intercept I was going to put in. So we have this. Okay. All right, so from here on out, I am just going to focus on this piece. So we are just going to focus between -pi over 2 to 3 pi over 2 as our interval. And then we'll just know that it repeats. So we're just focusing in right between two of those asymptotes. So now it's time to look at derivatives and see what's happening here. So I'm going to need a fresh page for this. So to find the derivative, we got another quotient rule. Seem to have a lot of, I don't know what's going on here. Lots of quotient rules today. All right, so we have low, d high is -sine x, minus high, and d low is going to be cosine x over the square of what's below. All right, so that's going to mean our numerator is -sine x minus sine squared x minus cosine squared x all over 1 plus sine x. Now I'm going to factor out a -1. So that's going to give us sine x plus sine squared x plus cosine squared x all over 1 plus sine x. And then right here, let me circle this. Sine squared plus cosine squared. Hopefully you recognize that from your favorite Pythagorean identity. Sine squared plus cosine squared is 1. So we have negative 1 sine x plus 1 over 1 plus sine x squared. And now we have something that can cancel out of that, which is kind of exciting. Cancel that, cancel one of those. So our first derivative turns out to be negative 1 over 1 plus sine x, which is nice. That's a nice, simple, neat. So now we want to look at critical values, potential minimums and maximums. Remember, we are only looking from negative pi over 2 to 3 pi over 2, just focusing on that interval. So when we set this equal to 0, it doesn't equal 0 anyway. And then we also need to think about where it's undefined. Well, it's only going to be undefined where sine x is negative 1, and that only happens here at this endpoint. So we don't have any critical numbers on this interval. Now, we can still plug into the first derivative and just see what's happening. So if we plug in 0, we get a negative divided by a positive, so it's negative. So what this tells us is that our function is decreasing on this entire interval. Okay, so our function is always decreasing, and I'm going to jot that down over here. Always now, so we know that this is going to look, I don't know, kind of like this because it's going to be decreasing, but we still want to look into concavity because we want to know, get a really good idea for what that curvature is going to be like. Okay, I just don't want to slap it on there. So now we're going to go, I need just more space to write. So our first derivative was negative 1 over 1 plus sine x. And now we're going to find the second derivative and see what we can learn about concavity. So our second derivative is low d high, which is just going to be 0, minus high, which is a negative 1. And then d low is just cosine x over the square of what's below. Now, that's just 0. So our second derivative turns out to be cosine x over 1 plus sine x squared. All right, now that we have this, we want to set this equal to 0, see if we have any potential inflection points. Remember, we are only worried about negative pi over 2 to 3 pi over 2. We don't have to worry about anywhere where our denominator is 0 because we already decided that happens at 3 pi over 2. It's on the end of our interval. So we multiply both sides by the denominator. We are looking for the places where cosine x is 0. And when we think about our unit circle, that happens at pi over 2 and at 3 pi over 2. So pi over 2 is the only point that we need to think about on this interval. We're going to plug in some points into this thing, see what happens. So if we plug in something like 0, we get a positive number. And if we plug in something like pi, we get a negative number. So we know that is concave up from negative pi over 2 to pi over 2, and it's concave down from pi over 2 to 3 pi over 2. So it's concave up, and then it goes concave down, which makes pi over 2 an inflection point. So when we come back here, we already have pi over 2, 0. So we know before that it is concave up, and then that's an inflection point where it becomes concave down. So that's what this looks like, and then that is going to repeat every 2 pi. So our next intercept would be over in here, and this thing just repeats like that. And again because it's periodic.